Good morning, students. Today we will start a new topic, pressure exerted by liquids and gases from chapter 6, Force and Pressure. As I told you in our previous class that how solid exert pressure on objects. In the same way, liquids and gases also exert pressure on other objects on their surfaces. So like solids, liquids and gases, which are collectively known as fluids because they can flow, also exert pressure on other objects on their surfaces. But there is a dissimilarity between the pressure exerted by solids and the pressure exerted by liquids and gases. What is that dissimilarity? See, if we keep any solid on any object, then that solid as per its weight applies force on the unit area of that object. In this way, solid applies pressure on other object in a direction. But in case of liquids and gases, as I told you, they are fluids because they can flow. They can flow anywhere. So when they flow, they can move in forward direction, then they can move in opposite direction, they can move up, they can move down. So their movement, their flow is random. In many directions they can flow. So when they move randomly in many directions, in all directions, then they strike to the objects in different direction. In this way, they apply force on the unit area of the object in many directions. In this way, they apply pressure in many directions. To understand it better, we take the example of a liquid such as water. Now, take certain quantity of water in a sealed closed container. Now, that water flows in all directions. It flows in right direction, it flows in left direction, it flows up, it flows down, and it flows in many other directions also. So when it flows randomly in all directions, then it strikes, collides with different surfaces of the container. During this collision, it applies force on the unit area of the different surfaces of the container. So this container experiences pressure exerted by this liquid water in all directions. It experiences pressure in this direction also, in this. So it means container experiences pressure exerted by water in all directions. It is same in the case of gas also. If we replace this liquid water with a gas, then gas also moves, flows randomly in all directions, strikes with the surfaces or walls of the container and applies force on the unit area of the different surfaces of the container. So in this way, gas also applies pressure on the container in all directions. So fluids means liquids and gases apply pressure in all directions. It is not in the case of solid, because a solid applies pressure on the object in only one direction. So this is the difference between the pressure exerted by fluids and the pressure exerted by solid. Now, there are more interesting properties associated with the pressure exerted by fluids. But first of all, we will study the pressure exerted by liquids among fluids. To understand the pressure exerted by liquids, we will perform an experiment. In this experiment, we will take a tube or hollow pipe. Then we will tie a deflated balloon over its one opening, and from another opening we will pour water in it. Now what will you observe? We will observe that as we will pour water in it, we will increase the level of water in it. Then this deflated balloon will increase in size. It will elongate in size. Why? Because as we increase the water in it, that water being a liquid applies force on its surface, on its unit area of the surface. It means that water applies pressure on its surface. That is why its size will elongate, will increase. So this experiment shows that water or any other liquid applies force on the unit area of the object. In this way, it applies pressure on other object, on other surface. Now, there are many more interesting properties associated with the pressure exerted by liquids. And to know these properties, first of all, we will perform few of the experiments. First of all, we will take that same tube or hollow pipe. Then we will make a tape-like opening from its one side. Then we will tie a deflated balloon over this tape-like opening and close its bottom opening. Now pour water from another opening, from top opening. Then the level of water will be increased. As you will increase the level of water, as you will pour water in it, what will you observe? You will observe that as we pour water, we increase the level of water in it, that water flows down and that water also flows sideways and fill this deflated balloon. As this water fills the deflated balloon, it applies force on the unit area of the surface of balloon. In this way, water applies pressure on the surface of balloon. As a result, its size increases, it elongates. This activity tells that liquid not only applies pressure in downward direction but also applies pressure sideways. Okay, again I am repeating, water which is a liquid applies pressure not only in downward direction but also sideways. Now another experiment. In this experiment, we take a beaker of particular shape and size and fill it with water. Now make 3 holes in different sides but at the same depth. This hole is in left side, this hole is in right side, and this hole is in front side. So these holes are in different sides but at the same depth. Now, what will you observe? We will observe that water coming out of these holes covers equal distance or same distance. Why? Because pressure exerted by liquid at same depth is same. It does not depend on the sides, whatever the side may be, because these holes are in different sides. This is in left side, this is in right side, this is in front side. So these holes are on different sides but at the same depth. So they experience same equal pressure by liquid water. So this concludes that water or any other liquid applies same pressure at same depth at a given depth. Coming to next, we take one more beaker, fill it with water, and then we make 3 holes in its one side at different depths. What will you observe? We will observe that water coming out of the first hole, which is at the lowest depth, will cover shortest distance from the beaker. Then water coming out of the second hole, which is at greater depth, will cover more distance from the beaker. Then water coming out of the third hole, which is at the greatest depth, will cover largest distance from the beaker. This shows that at different holes, pressure exerted by liquid is different. Pressure exerted by liquid at this hole is least. That is why it covers least distance. Pressure exerted by liquid at this hole is more. That is why it covers more distance comparatively. And pressure exerted by liquid at this third hole is largest, so it covers longest distance. We can infer from this activity that pressure exerted by liquid increases with increase in depth and decreases with the decrease in depth. So as you go deep in water, you will experience more pressure by water. That is why deep sea divers, when they go deep in water bodies like seas and oceans, they wear special suits to withstand large, high, great pressure exerted by ocean or sea water on them. Now, have you noticed one more thing, that in these two beakers, pressure exerted by liquid is independent, means does not depend on the shape and size of the container. It is same at a given height despite containers have different shapes and sizes. So, overall, what are the important properties of pressure exerted by liquids? First one, liquid not only applies pressure in downward direction but it also applies pressure sideways. Secondly, pressure exerted by liquid at a given depth at the same depth is same. Third one, pressure exerted by liquid increases with increase in depth and decreases with decrease in depth. Last but not the least, pressure exerted by liquid is independent, means does not depend on the shape and size of the container. It is same at a given height despite containers have different shapes and sizes. Now our next topic is U-tube manometer. It is used to find out the pressure exerted by liquid. What is its structure? That I am going to tell you. Now you can see the structure of U-tube manometer. It is very simple. This U-tube manometer is made up of a U-shaped transparent glass tube. So you can see this is a U-shaped transparent glass tube. Its one end is fitted with a rubber tube which is then tied with a funnel. There is a stretched rubber film over the mouth of the funnel. So mouth of funnel is fitted or wrapped with stretched rubber film. Now, when the pressure exerted by liquid water is same, then the levels of water in both ends of U-tube will also be same. So, if you see that levels of water in both ends of U-tube are same, it means pressure exerted by liquid water is same, does not change. But if it changes, means pressure exerted by liquid water changes, then you will see a difference in the water levels in both ends of U-tube. How is that? As you dip this funnel with stretched rubber film in the water, so you very well know that as the depth increases, pressure exerted by liquid water on rubber film also increases. So it experiences more pressure of water. As a result, this pressure is transferred, shifted here. So this water level experiences more high pressure. As a result, its level declines and its level automatically rises. And then if you keep on dipping it, if you keep on increasing its depth, then this rubber film will experience more and more pressure of water. So high water pressure from here is shifted to this water level, and as a result this water level declines further and here water level rises further. Then you can measure the difference in both water level. This difference will give you the value or amount of pressure exerted by liquid. So in this way we can measure the pressure exerted by liquid water by this U-tube manometer. This is all for today. Thank you. Have a nice day.